Alright, so I'm on, this is home learning day 2 for coordinate geometry. I want to show y'all number 3. This, y'all haven't seen this type of problem yet, but it's one that will be on the test, so I want you to see it. And that's all I'm showing you today, so make sure you're paying attention. I ain't going to be talking for about 5 minutes, maybe a little bit more than that. So if you can't at least have that kind of attention span right now, make sure you got no headphones in there neither. Because when you get it wrong on the test, I want you to know it's going to be your fault. Alright. A square graphed on a coordinate plane has a diagonal with endpoints J and L. What are the coordinates of the endpoints of the other diagonal? So let me tell you what they're setting up here. They're telling you the shape is a square, but all they give you is the endpoints of one of the diagonals inside of the square. Based on that, they want you to find the other diagonal and then be able to draw the square from that. It's not hard to do. I'm going to show you how to do it now. Alright, so these 2 points they gave me, J and L, these are not points on the side of the square. These are points that make the diagonal, one of the diagonals of the square. So J is at 1, 5. L is at -1, -1. This is J, this is L. Let me zoom in. Like I keep saying, because I want to stress this to you, this is not a side, this is a diagonal. Being that this is a diagonal, I was doing mine in purple the other day, and you'll notice I'm going to do it again. Come over a little bit. Put my diagonal in. Using some kind of straight edge is going to be very helpful on especially this problem, because you might be able to do stuff without calculating if you use a straight edge. I know some of y'all be trying to freehand this, but it's best to have some kind of ID or something. And reason being because of what I'm about to ask you right now. And I'm sure Tim will be able to spot this for us. But Tim, this diagonal right here. So what I want to do, and let me talk about the square. You know a square has 2 diagonals that go through it. They're congruent and they're perpendicular, because you remember they create right angles. I know they're congruent, so they meet at the same midpoint. So what I want to do first is find the midpoint of this diagonal. That'll help me know where the midpoint of the other diagonal will be at. What's the midpoint of this diagonal, Tim? You should be able to see it. You got to read the coordinate correctly now. 0, 2. The midpoint y'all should be able to see is right here at 0, 2. Now I did that without calculating. But if you're one of those people who can't see and you just struggle, like I can't find the middle of a line, you can always use the midpoint formula. Y'all should still remember it. You're just going to have to label your 2 points, x1, y1, x2, y2. It's just kind of a waste of time to me, but if you're one of those people that need to do it, you need to waste your time. If you need to use midpoint formula to find that, you can do it down here. But we found it without it. But I just think some of y'all are going to struggle doing that. Not a lot of space down here. I'm doing it small. Sorry. Midpoint formula, y'all should remember, especially if you've been with me. So it's going to be 1 plus -1 divided by 2. And then 5 plus -1 divided by 2. 1 plus -1 is 0. Divided by 2 is 0. On the other side, 5 plus -1 is 4. Divided by 2 is 2. That is where me and Tim got 0, 2 from. That is our midpoint. We just saw it though. But if you can't see it, calculate it. I don't care what you got to do. I need you to be able to find the midpoint. Here, that's another one I'll do with y'all. I think I'm going to do 3 problems in here. Alright, after that, now you want to use the midpoint and these other 2 points, and you want to figure out the slope of this diagonal right here. This slope is going to help us be able to create our other diagonal. So I'm going to just do the slope twice. I'm going to do it from this point L to the midpoint and then do it again. It's going to be the same slope. I just want to show you that. So from L to the midpoint, my slope is going to be up 3, rise over run, and run into the right 1, 3 and 1. And you're going to get that same slope from the midpoint to the other endpoint, which you should anyway. So my slope of my first diagonal is 3 over 1. Remember, this is a square, so the diagonals have to be perpendicular. Tim, what would the perpendicular slope to 3 over 1 be? Negative 1 over 3. I want to write a perpendicular slope to that slope, which is negative 1 over 3. And then I want to use that. I want to use that perpendicular slope to find my other 2 points. I'm going to start at the midpoint over here, and I'm going to use this negative 1 over 3 slope. It's negative 1 over 3, though, so when I do it, go from the midpoint. What's my first move, Tim? Down 1. And then I'm running to the right 3. 1, 2, 3. That's going to land me right here. This will be one of my endpoints on the diagonal. On my other diagonal. That's going to be one of them right there. Oh, that's weird. To find the other one, this is the only thing you got to pay attention to. To find the other one, you need to go back to the midpoint, but you need to create that same slope. So you kind of going to have to go in reverse just to create the same slope in opposite direction. Sit down, son. Sit down. Create that same slope in the opposite direction. So I'm going back to this midpoint, and I'm just kind of going to go backwards. I'm going to go backwards 3, and then up 1. I'm just generating that same slope that I created from the midpoint going the other way. I went back to the left 3, up 1. This is going to be my other point. And this will be the 2 endpoints on my diagonal. My other one. I'm going to just draw the endpoints. I'm going to draw a line for them. So this is my other diagonal right here. And then they just want to know what those endpoints are. Read it off here. It don't matter which one you put in which box, as long as you got it right to. I'll start with this one over here to the left. Negative 3, negative 3. I mean negative 3, 3. I said that wrong. And then the other one is at positive 3, 1. Afterwards, you want to make your square, you can. It don't really matter. You just needed to find those endpoints of the other diagonal. But I'll make the square just to show you that it actually was a square once we found the right endpoints. While you at it right now, on your, what's the thing called? The walk around? Go ahead and put a star by number 5. Number 5 is going to be like number 3 when you get there. It reads a little differently because it doesn't say diagonals. That's what confused some kids. It just doesn't say the word diagonals on there. But it's doing the same thing, acting the same stuff. So just make sure you put a star by number 5. Understand that's like number 3. Alright, I'm going to do another one with y'all because I don't trust y'all. You know how this goes. Number 1, I'm going to do this fast. We did this yesterday, but I want to remind you because you will have to do this on the worksheet a couple times. It says 3 coordinates of a square, M-A-R-K, are those 3 coordinates right there. It says where is point K located? On this one, this is similar to the one we did in practice on our notes yesterday, number 3. They give you 3 out of the 4 points. You got to find the 4th point. What's up? Yeah, hurry up. 1, 4. Negative 3, 0. And then 1, negative 4. Like I say, once you connect those first 3 points, it kind of becomes obvious. where your third point should be at. You should be able to see it. I mean your fourth point. You should be able to see this over here somewhere. To figure out where exactly it is, all you want to do is use slopes. Remember, parallel sides, or opposite sides have parallel slopes. So I know my side over here is going to be same slope as this side right here. So I'm going to just mimic this slope. You can use this one too. It's just that you would have to kind of start from the top up here. I'm gonna mimic this one and then go down here and do it. Alright, so AM, that's the one I'm using. And then my count is gonna be up 4, over 4. So all I'm gonna do is take that same slope and recreate it down here. Up 1, 2, 3, 4. Over 1, 2, 3, 4. Once I recreate it, I land right here on this point, and this is going to be my fourth point at 5, 0, and I can connect to make the square. Five, 0. These are the only two I did all day, but I think kids been struggling on this other one they asked y'all on the walking around. So I might help y'all out with it on here real quick. The last one I'm doing though, I'm doing too many for y'all. Y'all need to struggle. I think it's number 7, yes. On number 7, this one gives you a rectangle. Goat. It says the coordinates of those. It says what are the coordinates of the intersection of the diagonals. Listen to what the question is asking you. It said they give you a rectangle, they give you the coordinates of the rectangle. Then after that, they want to know what are the coordinates of the intersection of the diagonals. Where do the diagonals meet? That's all they want to know. It's just one point. First, you need to graph the rectangle so you can draw your diagonals in. So, graphing 2, 2, 8, -1, 6, -5, 0, let's make sure I did that right. Look like a rectangle. After you get your rectangle on there, since they're asking you about the diagonals, you want to put your diagonals in. A diagonal from G to A. And just to try to use a ruler or a straight edge so you can be kind of accurate with it. And then O to T. So like I said, if you're drawing with a straight edge, you could probably get this without calculating. But if you're not, you're probably going to have to calculate. And I'll show you how to calculate. Like for me, I think I drew mine straight enough. They want this point right here where my two diagonals intersect. You know what that is at? Can you see it on my paper? What point is that? Yeah. Yeah, that is it actually. But a lot of y'all may not be able to see that. If you can't see that, that's at 4 negative 1.5 because it is a decimal for the second one. You can always do midpoint. But you could just do midpoint of one of the diagonals. Both of these diagonals are congruent. So if you do midpoint of either one of them, you're still going to get the same midpoint. You just pick one. Like the first diagonal is GA. So I will use G up here and A up here. I will use those coordinates and do midpoint. I mean, just make sure you label X1, Y1, X2, Y2. And then your midpoint formula, M equals X1 plus X2 divided by 2, comma, Y1 plus Y2 divided by 2. I'm going to just show y'all that means that, right? I'm using these up here, like I said, G and A, that's the diagonal. You can use the other diagonal too, O and T, if you wanted to. So my numbers that I'm pulling, X12 plus X2, which is 6, divided by 2, comma, 2, Y1, plus negative 5, which is Y2, divided by 2. And then I'm doing that math. 2 plus 6 is 8. 8 divided by 2, y'all should all know is 4. And then 2 plus negative 5 is negative 3. Negative 3 divided by 2. Negative 1.5. So me and Zach were right. We saw it just by drawing it well. If you can't know, you can always calculate it. That is the other route you can take. 4, 1.5 would be the intersection of those two diagonals on that rectangle. Like I said, even if you use O and T, you're going to get 4. Oh, why y'all ain't correct me? Negative 1.5. 10-4. Alright, let me stop the video. That's for the kids who I don't teach.